Dear students, today we will learn zeroth law thermodynamics. It is stated as when two bodies or two systems are in thermal equilibrium with third system, then these two bodies are thermal equilibrium with each other. Suppose body A or system A and system B. System A is thermal equilibrium with C. Also, system B is thermal equilibrium with C. Then A and B also thermal equilibrium with each other. Okay, thermal equilibrium is what? Thermal equilibrium. Thermal equilibrium means what? There is no net thermal energy flows from A to B, and there is a permeable route between A and C for transfer of heat. Other way we can say that the temperature of A and C if same, then no thermal energy flows from A to C or C to A. Both having the same temperature, isn't it? Also, B, if is having same temperature with C, it means B and C are thermal equilibrium with each other. For example, if for sake of convenience, we can say if the A has the 55 degree Celsius temperature, it means C is also 55 degree Celsius temperature. Okay, therefore there is no heat transfer from A to C because both are in thermal equilibrium with each other. Both is having the same temperature. Then if B is thermal equilibrium with C, it means the B is also having the 55 degree Celsius temperature. Therefore B and C is also in thermal equilibrium with each other. It means the B and C is having the same temperature. Ultimately, we can say that A and B also thermal equilibrium with each other. Suppose one example is there. There is a system A and B and system C. System A and B is separated by non-conducting separation is there, but A and B are connected with C. There is a conducting separation is there. Conducting separation means thermal energy can be flow from A to C and thermal energy can be flow from B to C, but thermal energy cannot flow from A to B because it is a non-conducting band. Then if A and B at the starting having the higher temperature and C is in lower temperature, then A can transfer thermal energy from A to C and B also from the thermal energy from B to C up to A and C not achieving a same temperature. When A and C having the same temperature, then it means they achieve thermal equilibrium, and B and C having the same temperature, then it means they achieved thermal equilibrium. Okay, therefore at the last the temperature of A is also same, C is also same, and B is also same. Okay, it means A is thermal equilibrium C, both is having same temperature. B is thermal equilibrium with C, it means both is having same temperature. Ultimately, or easily we can say that A and B are thermal equilibrium with each other, A and B having the same temperature. This is all about zeroth law, and it's an easy for understanding. Then next is first law of thermodynamics. First law of thermodynamics. Okay, we can state it as energy neither created nor destroyed, but it can be converted from one form to the other form, and total energy of universe remains constant. Okay, we can write here energy neither created nor lost it, but it can be converted one form to other form. Total energy of universe remains constant. Remains constant. Energy can be transferred one form to the other form. For example, if you are having the cell and you put it inside the battery, it gives the light energy. The chemical energy is converted into light energy. If you having a car and you put the petrol, it can be run. Therefore, this is the chemical energy is converted to mechanical energy. Mechanical energy means displacement is there, such that if sunlight falls on a tree, it grows. Therefore, light energy is converted into chemical energy, isn't it? Sometimes we eat food and we can do our daily life works. That is, it means the chemical energy converted into our mechanical energy. Okay, this is a number of forms of energy. One can convert it from one form to the other form, but ultimately at the last the energy of universe remains constant. For sake of convenience, I have taken one example here. If suppose there is a isolated area in a sea, okay, outside there is sea, and there is 4 people are living there. Okay, this people isolated system means that there is no energy is transferred outside. Okay, there are no mass is energy and mass is not transferred from outside. That system is isolated. For sake of convenience, we take one example. There is one area in the sea. These 4 people are living there and they cannot move from this area. If these four people have each is having the 50 rupees, every day they meet at the evening and they having these rupees, they count these rupees at the evening and every day. But when he tried to buy some things or goods from his friend, he give him 25 rupees and it is having 25, gives him 25 rupees and buy some goods from this friend. This is also given the 40 rupees to this. It is having remaining 10 rupees plus 40 rupees. And at the evening, they count their rupees. They found that the 75 and the 90 and 25 and 10. They found that total their currency is remains 200. Okay, 25 rupees given to this friend and some goods is given from these friends to this. That 25 rupees converted. Okay, 20 is a goods, you buy some goods, that 25 rupees is converted into other form. Like that way, the energy can be converted from one form to the other form, and at the end, the total energy of universe remains same. Okay, this currency is not go outside from this area. Therefore, they buy each other things, goods, but at the end, at the evening, their currency remains the same when they count. Like that way, the total energy of the universe remains constant, but it can be converted from one form to the other form. There are number of statements for first law of thermodynamics. The second statement, the energy of any isolated system remains constant, but transformation of energy one form to other form takes place. Okay, isolated system is what? Isolated system is the kind of system from where no energy is transferred and no mass is transferred. Okay, then next statement is when some form of energy if disappear, the other form of equivalent energy is appeared. This is a third statement. If some form of energy disappear, some form of energy appear. Okay, the energy transfer we discussed in previously. Energy can be transferred from one form to the other form. Chemical energy is converted into mechanical energy. Light energy is converted into chemical energy. Number of forms there is interconversion takes place, but the total energy of universe remains constant, or total energy of any isolated system remains constant. And next statement is very easy statement, fourth statement. We cannot produce any perpetual machine. Perpetual machine means the energy run without energy. For example, your bike is run without petrol. Is it possible? Is it not possible? Without consuming energy, no work is produced. That is the fourth statement. There is no any perpetual machine can be produced without consuming energy. These are the four statements. Anyone you can remember is for first law of thermodynamics. Then for recapitulation we can hear the mathematical formulation of first law of thermodynamics can be given as: if there is a cylinder is there which is on a reservoir, hot reservoir means that is having the temperature is higher than this, and piston is there. When heat is provided from this hot reservoir to this cylinder which is filled by gas, then due to this, you know that gas is expanded when the temperature is increased or heat is given to the gas is expanded. Due to given temperature, gas will be expanded, and also piston is moves to upward direction. Okay, it gives the energy means it gives the heat. Okay, energy transfer by heat. Okay, we previously our first lecture we found that the Q is not energy but it transfer energy from one system to the other system. It gives Q energy is given to this system. Okay, Q energy is given to the system and expansion of gas takes place. Expansion of gas takes place. Due to this, the piston is moved. Any displacement means work is done. Okay, expansion is a kind of work where it is a kind of negative work. Expansion is a kind of negative work. Remember this. And compression is the positive work. Okay, therefore the work is done by on system is a always negative. Remember, expansion work is negative and compression work is positive. Due to given heat is given to this gas gain the energy. Okay, because Q is transfer the energy. Remember that. Due to gas gains some energy, therefore due to gaining some energy, the internal energy of gas increases. Okay, very easy things. It gives the energy. Gas gains some energy, and due to gain energy and expansion of gas takes place. Therefore, the piston is moved. If there is a displacement, then it means there is some work is done. Okay, then by providing heat, you can say that there is some internal energy of gas increase, and due to piston is moved, there is some work is done. Okay, easy equation we can derive. Due to given Q heat, there is internal energy increases. How much internal energy is increases? If suppose first is having U1 and second is having U2, then total increase in or change in internal energy is equal to U2 minus U1. Okay, this is delta U means the total energy is gained by this gas. Okay, there is change in internal energy, isn't it? Therefore, we can say that there is a change in internal energy is there due to this Q is given to this system plus some work is done. Okay, work is the formula when there is a such type of container is there, piston and container is there. Then some pressure and volume type formula is there. You remember this formula? W is equal to P into delta E. Okay. Change in volume and pressure is the formula. Pressure into change in volume, it gives the work done. Isn't it? But this work done is the negative because expansion of gas takes place. Okay, remember that when there is an expansion of gas is there, definitely that work is the negative one. Therefore, Q is equal to delta U plus your work is P delta V is the negative thing because there is an expansion. Okay, then Q is equal to delta U minus P delta V. Therefore, internal energy can be calculated Q plus P delta V if there is an expansion. This is the expression or mathematical formulation of first law of thermodynamics. I hope you got all these ideas. Thank you very much.